welcome back. Today let's try to solve another Leetcode problem. 59, spiral matrix 2. So we are given a positive integer n, generate a n times n matrix filled with the elements from 1 to n squared in spiral order. So this means if we are giving a number of n equals to 3, so it means we'll have a range of 1 to 9. So it will be ordered in spiral. It means this is 1, 2, 3, and in spiral order until it goes to 9. Let me go to the whiteboard to explain it and then go to the code editor to finish the coding. So we're gonna have a spiral matrix, we're gonna have a number like this. So we're gonna have a number of 1 to 9, and this is our spiral matrix. And we need to return this matrix. So we just need to prepare a counter. So this counter will be start from 1 until 9. So for each of the position, we're gonna fill in one number until we filled all of the numbers. So what should we do with that? Yeah, we should define some borders. So for the top, we're gonna define a top, it will be equal to 0, and the bottom equal to n minus 1. So here, the bottom will be equals to 2, and also the left and right. So the right should be equal to 2 because n minus 1 it is 2. 2 is this position, and the left should equal to 0. If we prepared these variables like top, bottom, right, and left, now we're gonna loop one by one. First, we loop through the first rows. We're gonna have a 1, 2, 3 filled in our result. So our result will be a 2D matrix. So it will be a 2D matrix. Inside, it will also be a matrix. There will be many of them. Yeah. When we finished putting the first rows, we're gonna delete this row. So how should we delete? We just need to use the top plus 1. So we're gonna, for the next time, we will not count this first row anymore. And then we're gonna count the second, the third column. This means we're gonna put 4 and 5 into our result. So it will be starting from here. We're gonna put 4 and 5. Yeah. And for the next step, we're gonna put 6 and 7 inside. After that, we're gonna put 8 inside. And for the last, we're gonna put 9 inside our matrix, inside our result. But how should we control that? We should always control that by choosing the top, bottom, left, or right variables. For example, as I explained, if we use the top 0 equals to 0 first, it means the top will plus 1. So for the next time, we're gonna not use this first rows. And then for the next loop, we're gonna use the border will be from the top to the bottom. So the top will be start from 1 and the bottom will be 2. So we're gonna put 4 and 5 inside. And then we just shift the right variables. Before it is 2, now right is 1, so right will be here. Yeah, so for each of the loop, we always shift the top, bottom, left, and right pointers. Finally, we get the final result. Yeah, if everything is okay. Now let me go to the code editor to finish the coding. Actually, the coding is much simpler than I explained. I just need to define a variable result. So the result is just preparing some matrix, and finally I'm going to put the numbers inside my matrix. So the result will be 0 times n for I in range n. It will be exactly the same as the n times n matrix. And finally I'm going to return the result. But before that, I'm going to define some variables like top right. Let me make it clockwise. Top, right, bottom, left. Top, right, bottom, and left. And the top will be 0. It means from the top row, it will be the 0. And the right will be n minus 1. And the bottom will also be n minus 1. And left will also be 0. So this means here is the top row, here is the bottom row, here is the left column, here is the right column. Yeah, if we have those 4 variables, it means it's enough for us to loop through everything, every number inside the matrix according to the space rule clockwise. Yeah, and now I'm going to have define two other variables. I'm going to define a count and a target. So the count will be start from 1 and the target will be n squared. Now I'm going to use a while loop. So while the count less than and equal to the target. So for the while loop, I'm going to put the count, put these numbers inside my result matrix. Now I'm going to prepare the top. So for the top, just need a for loop. So for top will be the column. Yeah. For the top row, I'm going to put the column 1, 2, 3 inside. So for say in range, it will start from left and right plus 1. And why right plus 1? Because right is n minus 1. But for Python, we need 2 plus 1. It means the plus 1 will not include it. It will only include to the right, to the n minus 1. Now, we just fill in the matrix. So the result with the top, it means the top row, and with the columns, gonna equal to the count. After fill one step, for example, we put 1 inside, and then count will plus equal 1. After finished filling 1, 2, 3 in the top row, in the first row, now we're going to update the top. Top will be updated by 1, so the top will plus 1. Now we finish the top row. After finishing the top row, we're gonna go to the right. So for the right, it's also the same for R in range. Here will be the top and to the bottom minus 1. So this means that the top will be the first, the second row will be this number 4, and the bottom will be, yeah, the bottom, so the top will be, so this is top to the bottom plus 1. Yeah, because bottom is n minus 1, but for Python, we need 2 plus 1. It means it goes only to the bottom. Yeah, plus 1 is not included. So this is why the bottom should plus 1. Now we are going to put the rows inside. So the result with R means the rows, and here will be the right, it means the right column. And in the right column, how many rows? It will be 4 and 5. So we put a result R inside. So it will be equal to the count. After that, count should be updated by 1. So count should plus 1. So it means we finish the right column. So the right column will also be updated by minus 1. Yeah, because for the right, when it finishes this one, 4 and 5, it's gonna be to the left. So the right will be minus 1. Now we're gonna go to the bottom. So for the bottom, it's also the same for say in range. But here, for the bottom, it will be from the right to the left. Here, for the right, we don't need to plus or minus 1, because when we define the right, it is exactly the index, exactly the same as we defined n minus 1. So we don't need to do anything for the right. But for the left should minus 1. Because if the left is 0, 0 minus 1 is minus 1. It means minus 1 is not included, but 0, this 7 is included. And also inside, we're gonna need a minus 1. It means we are counting from the right to the left. Now we're gonna update the bottom. So the result with the bottom and with our columns should equal to the count. After that, the count should be updated by 1. So as you can see, it's basically the same. Yeah, we just need more lines of code to check it carefully to avoid a infinite loop. After that, the bottom should be minus 1, right? Because bottom finished, it will go up, so the bottom will minus 1. Now we are going to the left. So for the left, it means for row in range from the bottom to the top minus 1. It's the same. Here will be minus 1. It means from top to bottom. Yeah. Let me delete this black, empty black. And now my result will be the, let me check. will be the left, yeah? So the row with the left would equal to the count, and count should plus 1. And the left should also plus 1, because the left is at this side. After that, it will plus 1 go to the right side. So that is why left need to plus 1. So basically, that's the entire code. You just need to prepare some variables and then prepare a counter and a target. If the count is less than and equal to the target, we're going to update the 4 directions one by one and fill in the numbers count inside the matrix. So for the top, right, bottom, and left, you must do it like a clockwise circle like that. Now let me run it to check if it really works. As you can see, it works. And by the way, the time complexity is O(n) squared because it is n times n matrix, and we didn't use any actual loop. We only count the numbers one by one until we finished. So that is the O(n) squared time. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast, and the method and thinking is really simple. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.